All right. What I'm going to attempt to do right now is go through a factoring method, well, two factoring methods with trinomials where front number or the a value is not equal to 1. Those ones are often quite complicated and require a few extra steps. Basically, what they're going to end up becoming is a bracket of two terms, right? And so what we're looking for is sort of those two terms. We know that they're going to come from some sort of multiplication that looks like that, where we would FOIL. So the method on the right-hand side here is essentially a way for us to sort of work that out, right? We're essentially going to need two numbers that multiply to get our first term, which is our 3x squared, two numbers that multiply to get our last term, which is our negative 15. And so that's what those two, like I'm going to put some possible numbers into these four spots, right? And those are the numbers that are going to be in my brackets. And then I'm going to check whether I also get numbers that add to get negative 4x. So with 3x squared, I'm probably going to have 3x and x at the front of my brackets. Those are the only two numbers or variable terms, I guess you could call them, that would multiply to get 3x squared. So that's helpful, right? And then what we want is some numbers that multiply to get 15, negative 15. So that could be negative 3 and 5, I might try. But then when I mean try is I'm going to try sort of multiplying them up this way, negative 3x, and multiplying this way, which is 3 times 5, 15, 15x, and then adding them together here to see whether they add to get negative 4x, and that doesn't work. That doesn't work. So I'm going to need to try some other two numbers here that multiply to get negative 15. I could try swapping the negative signs, but then I'm going to get positive 3x and negative 15x. And even though that got me to a negative number, that's negative 12, not negative 4. So I'm going to have to try two other numbers that are completely different, right? So this is a little bit of a trial and error method. And if you're not interested in a trial and error method, then feel free to skip ahead in the video when I do this other method that's sort of fail-safe but takes a little while. Two numbers that multiply to get 15, maybe something more like, what's it called? It might be even 1 and 15. It could be. Maybe this is negative here. But then that's still going to get me 15x, negative 15x, and that's going to get me 3x. And then I've still got negative 12x. Actually, let's go back and try. I don't know if I think I just skipped over it by mistake. Perhaps maybe 5 here and 3 here, right? Because it's also possible that swapping those two spots might actually help me out. I think I might have hit onto it. Maybe I'm going to make this one negative here. Let's just try that. 5 times negative 3 is negative 15. Yes, okay. And then I go 5 times x is 5x. And 3 times negative 3, negative 9x. And then if I add those together, they add to get negative 4x. So it looks like my brackets are 3x plus 5. And I know it's plus 5 because that's a positive 5, and x minus 3, right? And this crisscross here is coming because this multiplication, 3x times negative 3, is this crisscross. And this multiplication, 5 times x, is that crisscross. And so basically, I've managed to sort of check my work while devising what my my binomial is going to be, okay? And then so that's the answer right there. And then if I'm solving an equation, then of course I need to do 3x plus 5 equals 0. Still on the camera, yes, right? which is 3x equals negative 5, x equals negative 5 over 3, so that's one solution, right? And x minus 3, the other bracket, equals 0, x equals 3, right? So if my method is correct, then I should get exactly the same brackets using the method that I'm gonna use on this side, right? But multiply that back through, and we can see that we're gonna get 3x squared minus 4x minus 15. Now, this method on this side, it takes a little bit longer, but every single time I use this method, I'm going to get my answer. So if you're not so keen on a trial and error method, then this might be something that you could try. This trial and error method is actually not so troublesome. It's actually quite helpful. And I find that this visual is this sort of table that you set up for yourself can be quite useful. There's a lot of students that prefer to use this method because it's quite visual. So this method here is very similar to factoring a trinomial where this number is 1. I'm looking for two numbers that add to get negative 4, always the number in front of the x, and two numbers that multiply to get a times c. So these trinomials are all imagined to have this form, this ax squared plus bx plus c form. And so that when I'm referring to the letters here, that's what I'm talking about. Right, so a times c basically in this case means 3 times negative 15. This number times this number gives me the target number that I'm looking for. And I'm looking for two numbers that are going to add to get negative 4 and multiply to get negative 45. So again, this isn't necessarily trial and error so much as it's just using math to sort of make your way to a solution. My advice when using this method is to take the number that that you multiply to get and find all the factors, all the possible factors that get there. So 1 times 45 works, 3 times 15 that I just did, 5 times 9. I think that's probably it. Yep. And then if I look at these, this is a negative number, so I'm going to need a positive and negative answer. If one of these is positive and one of these is negative, then I'm going to have to subtract these to get my 4. So 9 and 5 might work. And maybe in that case, I'll use 9 as my negative because that number ended up adding to be a negative. And it turns out that 9 and 5 work out. This is what I'm going to do now. What I'm going to do is I'm going to split the middle term, which means that I'm going to rewrite this expression now as 3x squared minus 9x plus 5x minus 15. So notice the 3x squared stays, the negative 15 stays, but my negative 4x has been split into negative 9x plus 5x. If I add those together, I get negative 4x, right? So I know that my expression is equivalent, but I've used these special numbers that I've been pursuing to try and split it up. Right? I could split the negative 4 into lots of different combinations of numbers, but it's this combination that's going to make something really cool happen in the next step. When I factorize, what I'm going to do is I'm going to factor by grouping, which means that I'm going to factor the first two terms only and the second two terms only. I'm just looking for a common factor. Right? So I'm going to divide the 3x. That's what divides by both of those numbers, leaving x and then minus 3. And then I'm going to factor this one. What divides out is 5. Divide 5 from both of those. I leave x minus 3. And what happens is that the bracketed terms left over end up being exactly the same bracket. And I can write this as 3x plus 5 in one bracket, x minus 3 in another. I can do that because basically this expression right here is saying 3x times x minus 3 and 5 times x minus 3. And this expression is also saying the same thing, 3x times x minus 3 and 5 times x minus 3, right? So they're equivalent. I didn't actually do math so much as I just rewrote that statement into different form. But if, again, I'm solving for 0, I can do the exact same thing that I did here. We'll notice that I end up with the same solution, right? But this way, this method has an advantage that I'm always going to be getting the correct answer. I know that I'm working my way towards the correct answer. It does have a lot of moving parts, and so choosing it as a method can be a little bit perilous, because it's like, well, can I remember all those steps? This method here, I think, is a little bit more visual, but it does feel a little bit like trial and error. Like, am I ever going to get there? Especially when we got hung up on trying to choose the numbers here which multiply to get. You can probably tell from this video which of these two methods I use most often. I use this one most often. But if you're visual, then that might be a way to go. Okay, hopefully that helped.